All right, everyone. Thank you for your time and joining the class on time. So we are in week 6, and we are going to talk about MySQL and various statistical techniques. Now, I'm sure you're familiar with aggregated function, right? Can you remember? Your aggregate function should be covered in your introductory database course. So although we are using or telling that statistical technique, remember this is not a course of a statistics, means it is not a statistics course, or it is not a course that deal with data science, but we'll be knowing some formulas or techniques that you can apply to gain statistical results for data processing. So it will be a bonus kind of thing, because we call this course is an advanced database course. So my intention is to give you some idea what are those advanced things we can do in with MySQL tool. So characterizing dataset. So dataset is a collection of similar data. It's not like kind of hetero kind of data. It's a similar data. Say demography of our class. If you collected data, all the student we have, their name, student number, age, date of birth, address, phone number, those are like kind of very similar data. So then we call it is a data set. So when you're characterizing data set, you can use some statistical tool that's available in MySQL. So let's read the slide, then I'll elaborate little bit, and we'll start from there.
Techniques for characterizing a data set, such as calculating descriptive statistics, generating frequency distributions, counting missing values, and calculating least squares regressions or correlation coefficients. Randomization methods, such as how to generate random numbers and apply them to randomizing a set of rows or to selecting individual items randomly from the rows. Techniques for calculating successive observation differences, cumulative sums, and running averages.
So I posted a PDF, and that I'm going to make available for you in your week 6. So let me find that in a new tab, and in week 6, I can make it available for you and the slide. So you will find all information in this chapter 10 statistical technique from your text. So I will encourage you to read this. Now let's go back to the slide. And you can see in the slide, we mentioned many things like randomizing method, random numbers, calculating successive observation, cumulative sums, running averages. So we are going to use some statistical techniques that so we may not cover everything, because we have time limitations, and I don't want to give you too much input because those are advanced. So we'll be using some aggregated function, and we'll cover some of them, especially average, variance, regression, frequency count. Those kind of thing we'll be covering in this lecture. But I will encourage you to read the book chapter that I posted. That has all those information with examples, and you can easily copy and run the codes. So say we need to use a table that's called test score SQL. And I supposed to add this test score SQL that will generate a file called test score. So I believe in my system, I already created this. And if I go here in the tables, I can see the table test score is already there. Now I need to give you the file so that you can generate. So it has columns, subject is, sex or gender, and the score. Score means frequency. Okay. So how do we analyze this table? So if you go back to the slide, and you can see we ran 2 queries here. Select from test score, and I'm going to show you in the terminal. Okay. And you can see this, it actually printed select all everything from test score. Now, say those are subject 1, 2, 3 or a serial number, and those are age of different people, say student of a nursery class, their gender, and their score. Score means say grade or something, whatever. So if you go do this, and I ask to do this command, that order by score. So if you go here, and you can see the lowest score is came first, and the highest score go first. And you can see here, in future examples, you can see there are 2 people, that subject number 2 and 7, their age 5 and 6, and they got the similar score 4. And they got the 2 person get the score 7, 5 just 1 person, 6 3 4 persons, 7 4 persons, and 8 2 persons, right? So see, when only we ordered this table, order by this table with score, we started to get some insight about the data. So that's we call it information. And the information is 2 people got the lowest grade or lowest score, and one of them is male and one of them is female. So I hope you understand what does it mean by statistical information or statistical data. So simply order by, make rearrange the table, and we get started to flavor of some statistics about that data set. So some descriptive statistics. Let's read the slide first.
A good first step in analyzing a set of observations is to generate some descriptive statistics that summarize their general characteristics as a whole. Common statistical values of this kind include the number of observations, their sum, and their range, minimum and maximum. Measures of central tendency, such as mean, median, and mode. Measures of variation, such as standard deviation and variance.
Okay, now maybe I can do the pause of the rec. You only know that what is the formula. So you can see this is the formula, and you put the score. Score means the column name. If you go here, this is the column name, and it will perform, that function will perform all those 1, 2, and 3 steps to calculate the standard excuse me, the standard deviation. And in this case, this is 1.83. And you can see it's subtract from the mean for every sample, right? I hope you understand. Okay, but the primary job is to remember the formula that you have for standard deviation. Okay, and again, this is not a statistics course, only the mathematical statistical formulas in MySQL will be introduced to you. Now let's talk about variance. What is variance?
The variance measures the average degree to which each point differs from the mean, the average.
Okay, and as you know, like standard deviations also measure how spread out. So how spread out the data. And variance is measuring the average degree which each point differs. So those are those like technical terms, but I'm going to cover you as detailed as possible. Now for variance formula, you will put the score, and score is the column that's maintain the score for individual, every individual, and their gender and age is posted there. As soon as you give this score to the variance, it will take all those 20 inputs starting from 4 and down to 10, and it will calculate the variance for you. Okay, and say if I run this formula, let me show you here, and you can see this is calculate the variance is here. So I ran all those commands and copy the code result for you in the slide. Now the standard deviations. Now in standard deviations, you can see there are different formulas, and also for variance, there is different formulas. So one is this SAM per sample, and this POP for population. Now, in standard deviation and for variance, there are two different of formulas available for MySQL. Now you can ask me why two different formulas. So that's why I added this slide here, also available in your book. It's called the degree of freedom. So if there are n number of data in a table, and if you calculate with n degree of freedom, then you should use this formula. And if n minus 1 degree of freedom, that's the one less than the total sample, you should use this formula. Now, standard deviation and variance are synonymous. So this formula and this POP formula, means population formula, and only variance and variance population are synonymous. So you will see a same result. That's why I actually asked in your lab practice day, you will run all those commands with the same data set, and I'll see the difference among those formulas. That's actually one of the lab tasks that I want tomorrow. Now, degree of freedom is nothing but the number of observations, so number of independent piece of information in the data that are free to vary when estimate the parameters. And now what is independent means? So you know those are different subject, right? Starting from 1 to 20. And those are different individuals with different age and different gender or sex, and their scores. So all scores are independent. You understand the degree of dependent? Now, what is the dependency between two variables, and there is no, means that two variables are when dependent and two variables are not dependent, means discrete. So again, it is not a statistical class, but for sake of learning, we can so degree of freedom is important when you will be measuring your standard deviation. But again, I'm just introducing you those functions or built-in functions that's available in MySQL. That's the main idea for this course or for this content. Now, necessity or importance of standard deviation. So let's read the slide first.
Standard deviation can be used to identify outliers, i.e., values that are uncharacteristically far from the mean. Outliers can change the results of the data analysis and statistical modeling. It may cause a significant impact on the mean and the standard deviation.
So simply a outlier value is something that's not consistent with the values, and that's actually affect the various statistical measures. Let's go to the slide here when we printed different statistical measure here. So the average or mean is 7. And if you go here and see, the difference between 4 and 7 is 3. And from the highest, 10 and -7 also 3. So see how uniformly is distributed. But say if we have a grade here like this, 40, then if you subtract 40 or 7, then this 40 will be outlier. Or say those scores are temperature. If I give -15 1, then you see the average will be dropped significantly just for one value. Or for 40, the average will be changed significantly. So this 40 value is outlier. I hope it makes a little bit sense for you. I'm not sure. And that's why outlier is not good when you are calculating some statistical measures. So that's a little idea, but this is not, this will not be coming to your exam. Okay. Or I mean, the concept might come, but not the formula will come. Now calculating the descriptive statistics for groups. So here in this slide, we calculate the descriptive statistics, but individually, right? Not in a group. But in this slide, we are going to calculate the statistics by the age. And then every age group will be presented separately. So if I go here and go there and put this command, and you can see there are 1, 2, 3, 4, 5 different age group is there. And 5 age group has 4 members. So let's go if it is true. Let's see here. And the sample number of 4. So 5 group members. Score is 4. So there are 5 group members there. They have 1. So 5, 1, 2, 3, 4. And that's all. So you understand from this output that there are 5 members who has age of 5. Similarly, 9 has 4. Oh, interestingly, it's uniformly distributed. So every age group has 4 members there, whatever their gender is. And their sum is 22. So you can see this standard deviation or mean means average is different. So in a general, it was 7 point something, but when you distribute in the age group, only this one is closer, but all other is different. I hope you understand how does this age by age group is working. So I posted this output here. Okay. Now the same thing if we do it by sex or gender. So let's go copy this code and running here. And you can see, because only there are 2 types of gender there, male and female, and you can see 10 persons or 10 students, whatever, they have a male participants and 10 is female participant. And you see the different statistics here. And the mean is 7.1 and 7.5. That's actually the very close to the general mean. That's interesting. And if you actually divide, make an average of 7 plus 0.1 and 7.5, the average will be 7.3. So that's the general mean. And you can see here, the general mean is 7.3. So you understand how statistics is correlated. And the group and the total mean is pretty close because we are using the all samples to creating that statistical results. Isn't that interesting? I'm not sure if you are getting the vibe of this topic. Okay, so we saw that age, we saw that by sex. Let's use with the both. So they will group it by gender and age. So let's run the code again. And you can see this is by age and sex or gender. And you can see this kind of statistics here. And the mean, again, different. Standard deviation is different. Variance is difference. Okay. Now generating frequency distributions. So now you can see here, because that's why I actually added this result. You can see they scored 2 or they score 4. How many? 2. And score 10 is 2%. And you can generate the same statistics if you go use this. We are in slide number 15. So let's read the text first.
To know the frequency of occurrence for each value in a table. A common application for per-group summary techniques is to generate a frequency distribution that shows how often each value occurs.
Right. So in that case, we are doing group by score so that they will find the each score group from the raw table. And if we run this code, you can see the score 4 has 2 counts and the score 10 has 2 counts that we saw in the very beginning here. So this 2% 10 and 2% 4. And all others say the highest frequency is 5, and that's the score 9. And if you go in the raw table, you can find the 9 will be here. 1, 2, 3, 4, 5. Now we can do the grouping or statistical technique, applying statistical technique. We can easily find this without manual counting. And you actually cannot count manually when the data set will be 150 columns or rows, 150 rows, you cannot count, or 1500 rows, you cannot count. Then we have to rely on those statistical techniques or methods. Okay. Now, expressing the result in percentage. Now, say we have those scores, excuse me, in numbers. Now, how do we present this in percentage, right? Because percentage is a measurement that we can easily feel how big or how small it is. If I say 50%, then you will know, oh, that's a big number. If I say, oh, only 1%. So without going to the detail of a number, we can easily gauge how big or significant the amount is. So that's the significance of knowing percentage. So if I go here, run this code, you can see they score 4, only 10%. And in the count is 9 was the maximum. And you can see the 9 is 25%, the highest score. So you know, like these statistics give you different flavor of information from the raw data. Okay. Now graphing. So I'm point. So why do you need to learn MySQL graphing? You know, like you never know which tool will be useful for you. So I just give you an idea how MySQL graphing tool works. So so is knowing more is never be a negative thing. So I thought probably it will be beneficial at some point. So let's see what is MySQL graphing works, or how the MySQL graphing works. So let's read the slide.
One typical use of frequency distributions is to export the results for use in a graphing program. But MySQL itself can generate a simple ASCII chart as a visual representation of the distribution. To display an ASCII bar chart of the test score counts, convert the counts to strings of asterisk characters.
Right, so in the test score count, you can see, if you go in test score count in here, say age group 4, or the score 4 has 2 counts, 5 has 1 count, 10 has 2 count, and 9 has 5 count. So can we present this as a graph so that without reading the number, we'll see graphically which frequency is larger? And you can see easily, we can see here, this is the larger and this is the smallest frequency, and this is the code. So we select the score, and this repeat work as a loop, and we name it as count histogram, and this column is count histogram, and we apply group by the score, and we presented this by score. But this one is not using this table, rather this is using this raw table. It is not even raw because we use order by. So if you go just select all, this command, that will be using that table. So let's go back here. I mean this table. So it will pick all those frequencies from here, or the count from here. So let's go back to that slide. So graphics, let's copy the code and run here, and you will see it generate a graph. So those numbers, instead of putting those numbers, is putting those ASCII character. So if it is 4, then it put 4 ASCII asterisk sign as an ASCII character. So I believe you're familiar with this ASCII character. So those are binary or low-level code for the keyboard we are using. So all characters are presented with this ASCII number. And I believe if you took a course in digital systems, that's presented by those ASCII characters. Same way, we can present these group by and the percentage. So we can see this percentage table here is 10%, 5%, 25%. And this thing will be presented graphically so that you know this 9 has 25%. See how big this is, and there should be 25 histogram there. So let's see, go run this code. And you can see the percentage histogram showed up here. Now, while reading this, I hope you can remember this at means this is a user defined variable, and this variable doing some calculations here. So it is keeping some n, the values, and then it repeat it to calculate the score here, and then it's printed those ASCII character. And I believe if you count this, you will see 25 asterisk there. 4, how's the percentage for 4? Is 10, and 5 is 5. Let's go here. 5 is 5, so 2, 4, 5. So you see the percentage. So the absolute value of each percentage is presented by this histogram graph. Now, this part is our last lesson to calculating the linear regression or correlation coefficient. So say we'll be using, so let's go back to discuss something before going to this regression analysis. We are calling it of them that we have known data from previous. Because we have known data from the previous, we can predict the other. Now say, I can give you another example. Say we are in a pandemic and say there is a age and death. Are those dependent or independent? It's a critical question. We can say dependent because it is considered that if someone is 90, will die soon. If someone is age of 10, probably this person will go another 50 years at least. Say simple statistics. But age and death, you can consider is actually dependent variables. But in pandemic time, maybe it's a little bit independent, because 40 years people are dying, 15 years people are dying, right? So say we have known variable age. Age is known because we know the person age. Say all population of Canada, statistics Canada know what are the age population of Canada. Now, if you have unknown, say death. So say we have some data that age group 40 above or 50 to 60, this number of death. Age of 20 to 30, this number of death. Now, we can predict if someone age of 85, then we can actually predict the death rate in a pandemic of an 85 years old person. Did you connect?
Yeah,
Are you able to connect? I hope so we have some death and age in pandemic. So now say a person has a death of 85 or 45, and so we can predict the death. And I actually did an interesting work in fall with one of my project student in fourth year student. We did some interesting project. We predict some percentage of death people, like how likely of a age do die in a COVID. So we considered age and occupation. So we use two variables there. That's a complex regression analysis, but we had more variables. So we have two variables known, occupation and age, and we like to, so occupation is group by occupation, you understand? And age and death, this is the known to us, and we group it and try to find if you work in a whatever office or occupation or student or unemployed, then how likely you might be die from COVID. Because not
How
all.
accurate was that, Professor?
Huh?
What was the accuracy?
Oh, the accuracy, we don't know. We just use some data, like real data, government data, actually, we download that. I forget, like it is in one of the reports I have, so I cannot remember. So, but I can give you a general answer. The higher is, the death rate is more, because in Canada, and we work with Canadian data, so the population died in Canada is above 60. So if you have a smaller age or you're younger, you have less possibility to die from COVID. And it's the statistics. We know that, like, although for Omicron variant, many students infected, many young people infected in Omicron, although it's not that bad, but they still, the young people has very low death rate from COVID. Okay, so we'll be out of time. Let's cover the slide. So let's go back, share the screen. So I'm telling these stories to you so that you will be interested to know why you will be doing regression analysis. So we did I use this table so that you can see if I make it vertical, then something will be lost. So let's go see the output. And we only took two fields, age and score. And we are considering age is X and score is Y. And this is the formula for regression analysis. And those who know, this is a straight line, right? And equation of a straight line, X and Y. And A and B are constants, and X and Y are variables. One of them is known, or both of them are known, so that we can predict something using those unknown and known variables. Now, B is the intercept, and A is the intercept and B is the slope. Now, what is intercept? Intercept is when a line touches the y-axis. That's the intercept point. And slope is the angle between x-axis and the line. Okay. And here we are considering x and y. So age is x and score is y. To do that, we also need some other thing to calculate that. So those are those. Let's read this one.
The following equation expresses the regression line, where a and b are the intercept and slope of the line. Y equals bx plus a. Letting age be x and score be y. Also need the number of observations, the means, sums, and sums of squares for each variable, and the sum of the products of each variable.
So to calculate those two constants, we need to know, because x and y are known in the table, right? So we have the highest age here, 9. So if you like to calculate the score of someone, that is age of 15. So in that case, X will be known, age of 15, and we'll try to predict what would be the score of age of 15. You understand? And we'll be counting intersect point and B and A by using those sum square, and from those different parameters or variable. So let's do and run this code. So you can see these are calculating those sum square of different X values and Y values. And we are keeping it on those user defined variables. Okay. And after that, we are putting them in a table so that it look good. Let's go here. And you can see, because we printed all those variables, actually every row is same, right? This is an interesting learning today. I learned using those. And if I print this with this /G, then it will print it vertically. So let's find the code. Where is that? I probably did that. Let's go back here in this slide and copy the code from here. Here, I should remove this, otherwise. G. Go here and find. And you can see it's printed the table vertically, each row at a time. And in each row, you see all those variables are there. Here, this one is horizontally and vertically. So you can, I just take the one output from here. That's what we need for X, x sum of square, y mean, y sum of square, and x and y multiplication, sum of x and y multiplication. All those things we will be needing to calculate this x and y. So let's remove this g. Interestingly, this should work in the GUI, but in GUI this minus g is not working. So this is a good thing to tell you about. Let's go here, SQL, and paste here and go. It is not working. See, so I don't know, in command line it is working, in GUI it is not working, but I can show you something here and go here. You will be looking something interesting. See all those null, and can you answer anyone why this is null? This, okay, let's go back to the slide because will be almost running out of time. All right, we did this, and now this is the formula, and you can see y equal to, we are calculating the value of b and a, right? And it's the slope. Yes, go ahead, please.
Cannot see the screen.
Yeah, I'm going to share again. I'm sorry. Thanks for the reminder. Switching sometime. Okay, right there. I hope you can see. So now we are going to calculate the value of a and value of b. And if I go here, you can see this b and a. And this is the formula for calculating b and a. So we can put there, go here. You can see here this formula used to calculate the slope and intercept. So slope is b and intercept is a. And you can see here this value is there. Then so we have x and y. Now we got this value of a and b, so we can easily calculate this, represent this y equal to ax plus b. Now we have ax plus b. Now we can put x and y and calculate the unknown from here. And if you go in the table that we have raw, so if you like to predict a score of 9 is 10. Now if you have this is x. So say if you write 12, and if you put in the formula 12, you will get a value for a score. And that's the prediction doing for our regression analysis. That way we can actually predict the weather if we have some known data, and we can predict the unknown data from there because it's following a pattern, right? Now this is the formula because we have already known x, y, and a and b. This is calculating the correlation. So I am more interested learning the regression analysis. Correlation is the relation between two formulas. So at this point, those are those things. Let's wrap up. We learned today some statistical formula, mean, standard deviation, correlation, and how to do regression analysis using MySQL. And regression analysis will help you to know some existing data to an unknown data. And that's all for today's lecture.